Yeah, this is what being a mariner looks like now in 2026.
So the same stuff, just more.
Yeah, just be smarter. Okay,
Right.
you know, we're progressing up. Progress with us. So,
Right. Hi, and welcome back to the AI Captain's Log. Today we're diving into the world of manned and unmanned surface vessels. My guest today is Jack Dougherty. Jack is a seasoned maritime operations executive, U.S. Navy veteran, and a certified USCG STCW 95 instructor with 21 years of experience in both manned and unmanned operations across commercial and government sectors. His background spans hands-on maritime operations with extensive experience in remote operations, strategic USV integrations, and
yeah,
field deployments in both commercial and defense environments. He led the design, development, and operational testing of next-generation autonomous vessels, working directly with shipyards, OEM, and defense stakeholders to bring platforms from concept to mission-ready deployment. With a proven track record in strategic management and operational excellence, he specializes in integrating cutting-edge maritime technology to enhance capabilities and unlock new revenue opportunities. Jack is the CEO of Janus Marine and Defense. Domestically, Janus Marine and Defense works with the U.S. Navy, defense primes, research institutions to field test SUVs, train operators, and support real-world missions. On the commercial side, they assist port operations, marine contractors, and offshore energy companies in integrating autonomous platforms for surveying, inspection, and personal surveillance. Jack doesn't just build tech in the lab, he's the guy who makes sure it's actually working 500 miles offshore in 6-foot seas. Impressive. Jack, welcome to the AI Captain's Log.
I don't actually make them work. It's my guys make them all work. I just do this kind of stuff. So.
Well, we're happy to have you regardless. I'm sure you have experience before you actually got behind the mic.
A little. So, no, thank you, Elizabeth. Appreciate the opportunity and always happy to discuss autonomous systems, remote ops, anything that's, next tech, next gen level with in the maritime sector.
Well, I appreciate it very much, you coming on and talking to us about this. So one of the first questions I do have before we get started is, I think that not everyone understands the difference between unmanned and autonomous. So when it comes to that, I'm hoping you can shed some light on that before we dig in, because I do think some of the questions will come up later. We're going to talk about that a little bit more detail. So if you don't mind answering that first, I'd really appreciate it.
Yeah, sure. The easiest way to put it is you can think of remote control. It's just remote. There's still a human in the loop doing everything that needs to be done, making all the decisions. So which way is the boat going to be pointed? Which way is the camera pointed? All those things. What's that threat level? What decision am I going to make on this crossing as this vessel's coming towards me? Autonomy, and there's multiple levels of autonomy for if you talk about it with the IMO. And what it really gets down to is, how much are you allowing the system to make up its own mind, make its own decisions? And obviously the golden egg that everyone wants is vessels that fully drive like a person does, whether that's via computer vision-based autonomy, meshed with radar, AIS interaction. But that's just varying levels as it goes up.
Yeah, so when we think about autonomous and unmanned, we kind of think about them the same way sometimes. So thank you for that clarification. It is important distinction, especially in your world, because the human in the loop piece of it gets to be really important. Okay, so let's dive in. So one of the things that you face when you're looking at these vessels and they're out at sea for an extended period of time is the actual operations conditions that they have to work under. One of the biggest problems is that in the lab, it's really hard to test this. And there's not enough, from what I understand, there's not enough ocean labs out there to fully test. So, when you're going from the lab environment, and I know that you guys work with a lot of different systems out there. You're not necessarily a system designer, but you're a system tester. So you're working with a lot of systems that are out there. So when you look at these systems and they're going from lab to actually environment, what are some of the sort of conditions and fail-proof kind of things that these vessels have to have in order to operate in these unpredictable sea states?
Well, you're getting to the point now where you're able to negate some of that via digital twin engineering, where you're able to effectively take a proper digital twin model of a vessel and put it in real-world environments and run it for X numbers of hours and see what can shake loose, what the fallout is. But outside of that, the people who design the boats aren't the people that drive the boats. And then the people that do drive the autonomous or remote boats, they're not always able to facilitate the interaction of pitch yaw roll. You're going 40 knots and you're in sea state 3. You're not feeling the constant interaction with the vessel that you would if you were on it. And so all you're really seeing is just the camera jerking, and you're like,
Mhm.
well, it's fine. No one's on it. It just needs to get there. And that's where you start having, failures in the actual, whether it's the hull or the mechanical or the electrical systems. Things shake loose, they break, and so what you need to do to kind of alleviate as much of that as you can is obviously a dedicated testing with your asset. Starts in house in the lab, and then goes and it walks itself up from small harbor testing to actually out ocean going sea acceptance trials, and then endurance trials where you're going additional hundreds of kilometers at certain speeds to get your range, fuel, etc. And so just a graduated curve, so to speak, of testing that starts in the lab and but ends with really a human in the loop and a human on the boat, making sure that you can go 30 knots in sea state 3 without completely the boat shaking itself to death.
Yeah, and so these vessels also are not very cheap. So I'm assuming that you really don't.
No, that is. Some are. You can get. Don't Elizabeth. Don't be general. Some of them are relatively inexpensive, and some of them do a good job at that price point. But you normally get what you pay for when it comes to maritime technology.
Yeah, so I'm assuming you don't want to lose one. You want to operate them pretty efficiently when it comes to multiple different sea states, and you want to be able to not have to go through a lot of them during testing. So I would think that was a very important part of maybe what you guys are helping them with. Do you get involved at all in the testing of the new technologies when it goes out there, or do you actually only get involved when it comes to pre-deployment?
No, so we'll for Janus, we'll work with the OEM, the manufacturers, and we will help develop testing procedures for them. And then we'll also work with the end user who has purchased a unmanned surface vessel or UUV, USV UUV, that actually they don't really might not know the capabilities of the boat, and you really don't want the OEMs to test the boat themselves before it hands over to the client acceptance trials. It's like grading your own homework, you know.
Yeah.
You want someone that's a third party, that's a neutral evaluator that understands the restrictions that the vessel just naturally have and the current technological advancements, while also understanding what the concept of operations is that the client wants to get done. So you need to have someone in that happy middle ground, and that's really where Janus falls out.
So, not trying to get too proprietary here, but is there some particular sensor or some particular area that you find fails the most often during your testing?
Hmm. It's a good question. I would say a lot of times what it ends up being is electrical connectors. A lot of it gets down to force on force, and they just break. You're not thinking it in the same aspect. A lot of them, when you gauge it on the price point, boats are expensive, right? If you build an unmanned boat like a boat, it's going to be expensive because a USV is a computer and a boat, technically. Two things that you don't want to leave and put in the corner for 6 months and expect them to work. So you want to make sure that the equipment that's on that boat is the right equipment for the job, and the boat is built professionally. Now, on the other side of the scale, you can have attritable vessels that only need to go on a one-way mission, or they're just at such a low price point that you don't really care. And those tend to be built like a computer, just a floating computer. So kind of the gauge is, how often is it going to be worked? Is it a one-time boat? Is it an attritable asset? Or is it something that you expect to be out there for 30, 60, 90 days, with as few interactions with humans as possible, and you expect to get the best intel out of that vessel you can?
Yeah. So one of the other things too, I would think, is that what we face normally in any IT environment is hardware versus software. So, there's only so much you can do with hardware problems, and there's only so much technology you can apply to it. Realistically, soldering gun is a soldering gun,
Hmm.
right? I
Yeah.
mean, parts, so the hardware piece of it, it sounds like, is sometimes more of the challenge than the software piece of it, really.
Yeah, and if they'll talk to each other and how well they'll talk to each other and how well they integrate together and yeah, et
Yes.
cetera, et cetera.
Yeah, because every sensor, every single unit is built by somebody else probably. So it's a lot of integration, I'm
Yep,
assuming.
absolutely. So the guy that builds the boats, 9 times out of 10, doesn't build the sensor or the payload system or the camera. So yeah.
Yeah. Yeah. Yeah. So there's a lot of integration still. And that actually is something that I saw in your Janus report. I'm going to talk to you about
Sure.
upcoming. Yeah. So let's really talk about kind of the bridge between the boat and the mission. So and it really goes into the manufacturing and then this we're talking about the sensors and automating sort of what you're doing. So I noticed that when you talk about the right platform for, the right mission for the right platform that you mission. So I'm sure that there's something that, in terms of the autonomous, truly autonomous, and I'm not sure how much you guys work in that with the unmanned, but the truly autonomous, what are some of the mission killers and the truly autonomous things that you've seen that could possibly impact executing on that, like you said, the last mile or the wall of steel that we're going to talk about, or any of those other areas? What are those things that could come up?
Well, when you're talking fully autonomous operations, that's really not feasible at the moment.
Okay.
You're not going to just set it. It's not a Ronco set it and forget it. You need to have eyes on. Now, you can sit behind, you can be in level 3 control and have the vessel going out on itself and it's making its decisions, but you're going to have a human that's sitting there in the loop 9 times out of 10. Especially with the way that all the government regulations that are going on, no government at this point in time is saying, okay, we're completely happy with the performance of unmanned surface vessels and level 4 autonomy, so they're just going to be able to go. Not happening. But I mean, we're getting there. We're getting to that point. But that's what are some of the besides the regulatory things that are hampering autonomous operations with USVs is things like actual environmental state that can't be registered. The boat isn't going to know unless you put something like a Heffring marine sensor or on there and integrate it into the graphic user interface and into the system. The boat's not going to know that it's going in a sea state 5 condition and that you just told it. You said, "Hey, go 25 knots," and it's going 25 knots, and it unless you have the right sensors on board, it's not going to know that. It's just going to wonder why it's not able to consistently maintain 25 knots, and obviously it's sea state. So those are the things that you need to be concerned with, and people are looking at all sorts of different ways to get around that. So it's wave period recognition via computer vision cameras. It's sensors that interface, like Heffring Marine, like I said, that interface with USV systems. But yeah, I mean, that's off the top of my head, besides regulatory, which is the number one, I would say, environmental characteristics not being able to be properly judged.
Yeah, and so that really goes into some of those AI pieces of it that I like to talk about and think about
Mhm.
is that how close are we when it comes to autonomous and adding in that learning so that the autonomous vessel can actually go out there and make decisions and understand the inputs and turn that around and either correct itself, identify some type of security risk, or be able to understand and learn from that and make the right decision. How far away do you think we are from that?
I mean, you're exponentially advancing right now. What we started in, so Janus started in 2014. The leadership started in this field in 2014. My business partner and my two leads, they were all plank owners for an autonomous mine hunting unit in Bahrain. I jumped over and joined them over here in the UAE in 2018.
Mhm.
And, from where they were in 2014 to what we developed in 2018, it was still hit or miss, to be completely honest with you. You really needed to make sure you were doing everything by the numbers. You follow the checklist. If you fell out of, you need to put on, you power up the boat, then you power up the communications, then you power up the payload, and you make sure you check as you're going through the systems. And if you got anything out of whack or something just didn't feel like turning on at the appropriate time, you'd have to shut the whole boat down and restart the process all over again. Now here we are, 2026. That's not so much the case. A lot of the vessels now, it's one barrel switch turn. Everything boots up, everything comes on. You make sure you got comms, and you're good to do your pre-start checks. They're your pre-mission checks. So we're getting there. We're getting there faster and faster. But it costs money.
Yeah. Well, and the other interesting thing is it's a conversation I actually had at with someone at Tesla, and he's been there for 14 years, and we talked about sort of the transition from Tesla. And I actually had my first experience in a self-driving car. You think, I'm in this, but I was my first experience in one. And I was just asking him a lot of questions about the technology. And one of the things that he said is they have millions of hours of cameras, millions of hours of learning that goes into the
Yep.
autonomous vehicle. And, you know, we're just not saying we're just starting in the marine industry, but we are not as advanced as the automobile industry in terms of getting those recorded hours and having that learning and that capability. And that's really what I was thinking about with that question is that, do you think, like you said, we're going exponentially. Do you think that in a few years, we're going to have enough information and enough data to be able to program these systems, to be able to make them smarter and be able to, brake like a car and
Yeah.
turn like a car, identify, hey, this is something or a person in the road, or identify, something in the sea that's not supposed to be there, that's not, animal life, that's not a whale, that's not a,
Hmm.
not a dolphin.
Yeah.
um, yeah, so that's what I'm thinking is that maybe we'll have enough footage by then, we'll have enough data to actually train the systems.
Yeah. So, first of all, you got to realize with a UGV, an unmanned ground vehicle, or an autonomous car, they're on one axis. I mean, they're driving on the road effectively. When you're talking about boats, you're on the sea, and so you are doing this the entire time, where a car just goes very straight and steady. And lidar works well on a car. Lidar doesn't work very well at sea. So yeah, it's just there's physical references to maintain track. Obviously the lines on the road to maintain the vehicle in the right lane. No lines out there at sea, and so
No.
it is harder for boats. But with the advent of effectively digital models that you can continually run, a lot of people use the Singapore Maritime data set. That's a very popular and famous data set that's used for computer vision, machine learning, to teach cameras that, hey, this is a trawler, this is a patrol boat. But it's learning. It takes thousands and thousands, tens, hundreds of thousands of hours to get to a consistent accuracy point where you would reliably say, "Yep, that's right. That's an Iranian fast attack craft." And the more that we're able to build models and internally train the models effectively using AI to train additional AI, the faster we'll be there. But right now, we're still working on that, and there's good companies that are doing it. There just are. I mean, Takaro Blue is good. Current Core is good. There's good companies out there that are working on this project.
Yeah, it's I'm really fascinated. I've always had the vision of the car that I can, just get in and just take a nap because I really don't enjoy driving. Um,
Okay. Yeah.
a vehicle on land. That's
Yeah.
I don't really enjoy driving.
Yeah. Yeah.
Um, and the boats have always had, you've always had your, auto routing and your auto
Hmm.
capabilities far before cars had them. So
Yeah.
you'd think, I mean, one would think who's not experienced like you are in this industry, one would think that, oh, well, they've had this longer. They can certainly auto route longer. Why can't they just make it happen like a car faster? So thank you. There's a lot more factors, but people don't think about it that way because I'm like, well, there's lots of room around you. When you're on a vessel, you don't have to worry about the lines on the roads. So if you
Hmm.
crash into something, you got more time.
Yeah.
Right. Yeah. Right.
Yeah, in my mind, it's unmanned ground vehicle or autonomous car, then UAVs, because effectively you can tell a UAV stay at 10,000 feet, and it'll get buffeted around and move, but it'll just naturally come back to 10,000 feet.
Hmm.
So, but then you're dealing with a boat that's just pitch, yaw, roll, seas, currents, wind. It's a lot. It just is a lot,
Yes.
and nothing is more demanding than the sea, especially in the environment, on the equipment. There is nothing that is as devastating to electronics, especially than salt water or water in general. And
Yeah.
the problems are just there, and they take smart people to overcome those problems.
Wow.
But you
Yeah.
know,
And luckily, we have smart people like you guys, and a lot of the people in the industry now are really looking at this. So maybe one day, I'll keep my fingers crossed that one day in my lifetime, I'll see some of these technologies reach my helm. But
I bet you
that's
will.
yeah, it'd be exciting. I'm ready. I'm ready. I'm there for it. So let's talk a little bit about some of the partnership you have with Raven Defense to build that wall of steel in Gulf of America. I think that's
Sure.
really interesting piece of what you're doing because I don't know if really people think about the security that we have to consider with energy and
Mhm.
with harvesting energy. I know that just as a side, there are also underwater vessels that are looking at the seafloor, mapping the seafloor as a part of this as well. You know, harvesting energy from the sea. But then when you get it built, I mean, these platforms, these oil rigs are not cheap. It is not cheap to build. And then you have to secure it. I mean, it's out there in the middle of, Gulf of America or
Yeah.
anywhere in the world. And you're having to secure that and make sure that, for us, who guards that if it's
Mhm.
not industry, who's guarding that, and how can we
Yeah.
take some, and look, you're looking at how do we take that pressure off of our forces, our US forces, to stay on their mission, and not necessarily, energy is everyone's mission, but right now especially with the AI race. But
Yeah.
um, can you talk a little bit about sort of that, how you're guarding, how you're using, or how people are implementing that technology around our energy sources?
Sure. So I'm from Texas. So I'm from the Gulf Coast and born and bred Houstonian. And so energy sector has always been a part of my life. But then I joined the Navy and I know how god awful boring it is to sit there in a riverine assault boat and go patrol around, energy infrastructure. It's cold, you're tired, you're wet, your gaze falls, you start losing your attentiveness. And, so the reason we're called Janus is the Roman god, two-headed Roman god. One looks to the past, one looks to the future. And effectively, Janus is filled with 50 CH-53 mine hunting crewmen who flew around in helicopters and did mine hunting, and riverines. And so, now both of those jobs can effectively be done utilizing equipment that is readily available on the market. And so, why wouldn't I want to do the exact same job from the comfort of air conditioning and heating and a hot cup of coffee in a nice chair instead of being fully kitted up in my body armor with an M4 and rocking a boat? So yeah, it just made sense to me. And with my team and how long we've been doing this, over a decade, effectively between all of us, we're able to bring that capability to the energy infrastructure. I live over in the UAE. There's portions of it that are being used over here. And then when the Venezuela incursion happened and we were able to replace that regime, there was quite a bit of floating metal there from the U.S. Navy and U.S. Coast Guard, and just seemed really expensive, to be honest, as a taxpayer.
Yeah.
And I just knew I could do something as it maybe not as good because I'm not a U.S. Coast Guard entity, but I could do something that's damn well pretty good. And I could get assets on in theater. I could provide persistent ISR coverage with long loiter USVs that could be out there for 30 days. I could provide high speed interceptors capable of 50, 60 knots to get out there and interdict these vessels. And not to mention that you can integrate as well with UAVs. And so you can have a full maritime domain picture of this energy infrastructure that's offshore. And Venezuela, most of it's in Lake Maracaibo, and that's you can see a lot of it from the shoreline. So all it takes is one or two extremists in a boat that really want to make a point, whether it's environmental extremists who don't like the fact that there is oil being pumped out of the ground, or it's someone who doesn't like the fact that there's been a regime change and they want to make a statement and they want to make everyone look bad, or make X energy infrastructure no longer a thing, and how much money is invested, and just embarrass people and in general reduce that revenue, make everything look bad. So I
Mhm.
thought we could do better. And the guys at Raven Defense, Chris and Mike, they agreed with me. And having their extensive experience working in the Gulf, They do interesting telemetry for rockets and sort, and they already utilize USVs. They utilize mothership operations. They were the right team, and that's where we kind of came up together and had this idea of taking their capability and projecting maritime persistent ISR out in the Gulf of America.
Yeah, well, that's fantastic. I certainly, it does take that pressure off the forces as well to do other missions that are necessary right now. So, there's a lot going on in the world, as we
Hmm.
know.
Yeah.
But I do think that that may be an ongoing thing as well, because there's certainly protection that's needed as we continue to explore, as we continue to look for, different energy sites, as we continue to, be able to build that infrastructure back out again. We're going to need protection for that infrastructure. So, do you foresee
Hmm.
this something that is like a model that will continue into the future? I'm sure you do, but
Absolutely. And it works in renewables as well as it works in oil and gas. It's same. If you have, and it doesn't matter, if you have a edifice that and a project that has cost hundreds of millions of dollars, you need to be able to protect it. And that might just be something so simple as having a USV patrol around and scaring away fishermen. Why? Because it might be, there might be marine mammal detection that needs to be going on. And, they want to make sure that no one is going to interfere with the transit lanes of the humpback whale or something along those
right.
lines. It works in all avenues just as well, if not better, than a manned vessel does.
Yeah, and I know this is a little more local for me, but I'm thinking about, when I'm cruising down the Chesapeake and I'm going past the power plant, there's actually the
Mhm.
cooling for the power plant is actually way out into, juts out into the bay. And, they have little beacons around it. They have little posts that you're supposed to go around and stuff. But I am sure that something even that small would probably seem like it could benefit from some type of protection that can just constantly monitor, constantly go around, have not just visual from the platform, but constantly go around and look for things, because you never know where something may come
First
up.
step. First step is presence. Just, I mean, most people will be deterred by just seeing the presence of whether it's a 3 meter unmanned vessel or, whether it's a 10 meter manned craft. It doesn't matter. Just the presence of knowing that whatever they were thinking about doing, if they were thinking about doing anything at all, they might be in the wrong place, the wrong time. They got lost. Happens all the time. But if they were thinking about doing something stupid, just knowing that there's that boat that's right there with this PTZ camera, that's immediately looking at you. It's registering your boat number. It's got your pictures on camera. All these things, just it'll most likely, unless they're really committed, it'll most likely scare people away, and that's all you need.
Yeah, it sounds like a really a great project, and something that definitely we need in our just help protect our energy sources, especially if we're going to win the AI race, right? We're going to win.
Yeah, hey, got to win.
Got to win. Got to
Indian
be in
is
it to
coming
win it,
second.
right?
Yeah, exactly. So got to commit.
Yeah. So I'm going to switch a little bit over to just sort of the human element of this, and really think about really the component that you guys do a lot of, and that's training the human operator,
Mhm.
and how to, what that looks like. And I know that you work a lot with the military on training the human operator, but you also work in general in the industry. So in terms of equipping, the human piece of this and training people on this, what are some of the things that, in terms of knowledge transfer, in terms of training, in terms of all the things that you need to get an operator ready? What are some of the things that you're seeing from, because you see a cross section of all of the different software, all the different USVs, you see a cross section of that. So what are the big challenges in that area that you're seeing?
So yeah, and some are better than others, to put it completely bluntly. But yeah, Janus is agnostic. We support various entities, OEMs, end users. We're just happy to see USVs out in the field working. And for us, because we do life cycle management as well, so more work that are boats that are working, it's more work for us. But it's not going to work if we have to run them all ourselves. Other people have to feel confident enough to take that asset and go perform a mission with it, whether it's commercial survey work or security. And so, you see a large swath of people who come into this, and some come from the science background, some come from merchant marines, some come from the military and security aspect. But the one thing they all have in common, especially because of where this lies in the field, is they're all excited to be doing this.
Mhm.
Rarely do we get someone who just doesn't want to be here. Everyone is excited, and they need to be, because it requires a little bit of everything. You need to be a jack of all nautical trades, so to speak. You need to know a little bit about software. You need to like video games a little bit. You need to be comfortable in front of a computer. But you also need to be able to get on a boat and drive a boat around. You need to have mechanical sympathy. You need to have mechanical understanding. It's just a little bit about everything. You need to trailer a boat, tow a boat. It's boating plus computing, and which is really where today's modern mariner should be headed anyway.
Yeah, and that's kind of where I started this podcast, because to me it's like, it's the cross section. It's where AI and IT meet marine, and outside of the military, I'm not sure how many of the other academies or maritime academies are actually teaching as much tech as they should. I don't know. I haven't been to one, so
I was chief of staff to the Texas A&M Maritime Academy under Michael Rodriguez, former deputy marit. Now, mind you, I left that position in 2018, but I still keep my fingers in the merchant marine pie, and they still, you don't want to be teaching people to be mariners the way that you taught 50 years ago. You need to be prepping them for the next 50 years and the next iteration of their career path, and whether they like it or not, it's coming.
Yeah.
You can drag your feet, kick your heels, throw a temper tantrum, but guess what? It's not going to stop anything. So, do you want to be part of the discussion of how these vessels are integrated, how the training is going to be, or are you just going to bury your head in the sand? 100 years ago, being a boiler technician was a great job,
Yeah.
or a sailwright. But guess what? Not anymore.
Yeah.
It's just not a thing. And so, I laugh. I mean, we're still teaching, celestial navigation.
Yeah.
And people don't like when I say this, but I understand if it's used as you have to pass to progress to the next level. But to be realistic and say that you're doing your noons, I mean, come on.
Yeah. Yeah. And yeah, it's a nice to have. It really is. Sort of like, it's nice to know how to glide a plane down if, you lose all your engines.
Hey,
So
agreed.
it's nice to have, and certainly, but is it the fundamentals? And I think that's what you're getting at, is the fundamentals, and really
Yeah.
what are those fundamentals going to be of the future? And, how do we prepare those mariners? And not just people like me who are out there, driving my personal vessel, but really, it's all it does eventually end up in the commercial space, some of these technologies, and it does eventually end up, something we can take advantage of and use. And it's basically the whole industry. It really starts with you guys who are leading sort of all of the different aspects in the military and all that learning from there. But then how does it flow into training a towboat captain, or training a water taxi? So it all goes down to the same thinking, really,
Mhm.
of what's the future going to bring for us. So, okay, so the last piece of this is what I like to call is the lightning round.
Yeah.
So I'm going to just kind of pop some questions at you. So one of the things that we talked about before, is really, how do we get that, the ghost in the machine kind of thing. So when you talk about AI pilots, and you talk about things we talked about before, is there something, like I asked about the hardware before, but is there something in the smart software or in the dumb hardware that you, in your experience, like we talked about this before, but it really does catch you, as the human operator? That's like the thing that's always the gotcha. Like, what is that thing that's going to be like when you're doing the training and they're like, oh, dang it, we missed that,
Yeah. No, you'd be comms. So yeah, communications. Whether if you're inland and you're trying to run off 4G, 5G, micro hard radios, if you're you're over the horizon OTH ops, and you're trying to run Starlink or Starshield, you know, so Starlink's great. Everyone's using it now, and it's amazing. Except now that you have this unlimited amount, no one is worrying about data compression anymore. So you're just sending every single thing through all your sensors across this pipeline, and no one cares anymore. Well, we were up in Finland at Task Force X last year, and not a whole lot of Starlink satellites up there above Finland. And when you had 40 or so USVs all throwing everything they have up into one Starlink satellite, yeah, problems. And, so data compression, whether it's, effectively think of like a zip drive, zip it on one end, pipe it through, unzip it on the other end, just basic comms thoughts and redundancies.
Yeah. That's interesting. I mean, I'd love to talk more about that, but I know we're kind of run up on time. So, but that's really interesting because I spent a lot of my career in networking or working on in the networking space, and certainly QoS for everything, and talking about how do you get data, how do you move data, and it's important. People sometimes lose sight of that. So, thank you for bringing that up.
Yeah, we didn't back in the day when we didn't have Starlink. I mean, it was all about how much could I reduce and keep as much bandwidth as possible so I could be as close to real time as I could. But Starlink's great when it's great, but when it's not and every single person's on it, no one cares anymore. Just all of a sudden
it's like
lag.
going to a concert where you can't send a text, or going to a concert, because everyone's in the same cell.
Exactly.
Yeah.
So,
yeah. So the next thing is about we talked about a little bit about this autonomous thing, but really, we're talking about that wall of steel. And what do you think, if you identify a target really, and you're doing this patrolling and you're going around, really, is there an interception point? Or you were saying you were kind of teasing about that a little bit about, depending on the mission. Is there an interception point, or kind of like, where does that go? Is there a green light? Is there like, oh, I've identified it, and the human steps in and says, okay, they're already operating it, but they sort of say, okay, this is not something a threat, or this is a threat. What does that really look like? In the field, remote operations center, when you've got something that's out there. What's those next steps?
Whether it's a UAV or whether it's a persistent ISR platform on the water, you want endurance. So with endurance, you need to minimize your battery footprint. You don't want to be sucking up as much as you can, with a very expensive $500,000 PTZ camera on a long loader asset. You're not going to be able to recharge. You're going to be on a constant drain. So, how it would normally work for us, the persistent boats that are out there for 30 days or so would spot an incoming asset on their fixed focal length camera. It would alert the remote operations center. We would be able to take whatever is the closest asset to it that can actually get up on speed, which would be a high-speed persistent ISR asset. So something that can't be out there for 30 days, but can maybe do 72 hours. You could get that over there fast. Or you have larger platforms like an 11-meter high-speed interceptor. It's got 1,000 gallons of diesel in it that's capable of going 45 knots with battery banks for days and a generator on board. And, you can go full speed out and intercept them and get proper eyes on. And at that point, you can make a determination of, hey, it's a threat. It's not a threat. It's some fishermen, they're lost, or possibly if it is a threat, then you can move to properly intercept. And the nice thing about an unmanned boat, there's no one on it. So if it is a proper threat, you always have the last resort of using that boat to push the other boat away and shoulder it out of the threat area.
Yeah. I'm sure it's exciting when it happens. Not always, in the best ways exciting, but it is certainly exciting when it happens. That you actually have to jump on. Because I know the way anybody works in that field, that's like their moment. They're like, oh, I can't wait to get, oh, wait, it's real. We got to jump on a boat. We got to go see. So, so putting that human out there, sometimes it's exciting, but also very risky. So we have to always keep that in mind.
That's it. I mean, I liked being that guy, but now, I can, with Raven Defense, we can run operations from Albuquerque, New Mexico, and the boats are off Venezuela or Colombia around the Panama Canal.
Yeah, it's
People
really
are good on
amazing. It's amazing what we can do and what we get eyes on. So going back to you mentioned working for the chief of, you spent time as the chief of staff for Michael Rodriguez. So looking at different areas of policy. So some of the things that you were talking about earlier are policy related. And actually, it's a really important question because as we continue to this down this road of all of these other vessels that are possibly out there kind of intermixing with commercial vessels and civilian vessels that are out there that are on the waterways. Really, you have to get into sort of the idea of the liability, the
that.
policy, meaning the COLAREG, and
Yep.
really the insurance. So, of those three, what do you think is the thing that we have to worry about the most with having all of this mixed in together? Because at some point, we may get to a point where we're all mixed in together.
It's already happening. In some aspects,
Yeah.
really, it's the liability. Because if your boat is flagged in Panama, it's
Mm-hmm.
running up in Norway, and you're in Abu Dhabi, we're controlling it from remote operations center. Who has authority? Who is the one that is can say, hey, I mean, okay, well, you're close to Norwegian waters. Are you, or what if you're in international waters, but you're close enough to Norway and things start going south? Yeah, that's the questions that need to get answered, and they aren't being answered very fast. I will tell you that much. And I don't.
Yeah.
Norway's great. I have absolutely nothing against Norway. Maritime Robotics, great company. Norway's always been. They've been doing it since 2005 up there. So that's just a country that I threw up. But yeah, you get my drift.
Yeah, yeah, for certain. Liability is always such a huge question, always. And everything lags behind when it comes to insurance, when it comes to liability, when it comes to policy. All those things always lag behind innovation. And that's always been a
Mhm.
problem. Okay, so the last question, and then we're going to wrap up. I know I've kept you a little bit longer, so
No
thank you.
worries.
The last question really is, I know you have really a passion for, that next generation that's coming up in the maritime industry. We talked about that,
Mhm.
about how do we train them. If you're giving a 19-year-old, a young sailor or a young coastie advice, or just a young person going into the maritime industry, what would you say that they should go into? Should they, like, what part of this should they go into? Should they, think about what their learning path is, and like we talked about that next generation, what do you think is going to be the most demand? I was just giving you an example. I was at the AI Expo and I saw all of these. It was great. They had Army versus Navy versus Coast Guard and
Mhm.
everything, running the drones and stuff. But really, I mean, it was air-based drones. We still have the same thing in the marine industry. We have sort of the drones that are out there.
Yeah.
But what would you say? What would you advise them? What would you say they should be focused in on or laser focused in on for this next 10 years or even 5 years?
That's an interesting question. So engineering is always great. You're always going to need engineers, and you know, I guess let me phrase this in a different way. I don't think in my lifetime or in the next 100 years there will always be people on board vessels. Always. Now, how long they're on those vessels will change. Now, I don't need a full complement of crew on a 300-meter VLCC that's coming across from Med across the pond going to the East Coast of States. I don't need it. As long as you've got the right systems of systems on board to tell you, hey, this is life expectancy of this pump, and I fulfill it where when we get 200 nautical miles from the coast of the U.S., a helo lands and disperses, a pilot, the engineering team for maintenance, etc. There is nothing that says that can't happen, and you're still utilizing the same people.
Mm-hmm.
You're just not requiring them. They can be in a remote operations center for that long 6-7 day transit across the pond. But they're still mariners. They're still going to go out and get on the boat. They're still going to get their hands dirty fixing motors, engines, pumps, etc. You just need to truncate the PMS, the preventative maintenance system, for those times when there's people going to be on board the boat. And that's where systems of systems come in, like the NOMARS project that boat's supposed to be completely unmanned for a year. Well, how do you do that? You have to have systems for systems. So you might have an autonomous pump, but you need another system that's telling you what's the life expectancy left of that pump. How much longer do I have before I think that's going to give way? So I know I didn't really answer your question on where they should start or where they should focus, but I do think that there is always going to be, in the next 100 years plus, there's always going to be a need for real mariners, real experience. The mechanical sympathy and the hull sympathy that you get as a decky, knowing what a boat goes through because you've been on the watch floor, you've been standing on the bridge, that's worth its weight in gold. You can't get that without doing it. But that mentality needs to be brought indoors to the remote operations center as well. So do everything. Just do everything. Don't turn anything down. There's opportunities. University of Southern Mississippi does a lot. They've got, they give certificates for unmanned systems. There's OPT. There's AUVSI has they've got sponsored classes. OPT has a class. We do classes. We teach. Get your hands dirty. Get out there. It's fun. I promise.
Yeah, it almost seems like you still need to be the jack of all trades in the maritime industry. It's really one of those things that you have to know how to fix an electrical issue all the way down to a plumbing issue, all the way down to your charting issue, all the way down to fiberglass.
Exactly. So I mean, if you want to be a mariner,
or
this
welding,
is what being a mariner looks like. Yeah, this is what being a mariner looks like now in 2026.
So the same stuff, just more.
Yeah, just be smarter. Okay.
Right.
We're progressing up. Progress with us. So.
Right. Thank you, everyone, for joining us today. I really appreciate your time, Jack, and we really appreciate everyone listening, and hope you learned something from this as I did. So appreciate it.
No problem. Thank you for inviting. And if anyone's interested, we do a yearly annual called the Janus Review. It's free to download, kind of give you an idea, an insider's look. We had great people correspond with us on this one. We had we had Raven Defense, we had Maritime Robotics, OPT, Sound Maritime Solutions. We just had some open ocean robotics. So you're getting an insider's view of what the USV market is, what the challenges are, from people that do it every day, like myself, and all the fine guys at Janus. So appreciate it. Thanks for everything.
Yeah. We appreciate it very much, and I have to say the Janus Review is very comprehensive. It's a great publication. So you said you're going to start doing that quarterly?
Yeah, hoping to. So we've been doing it the last 3 years, and it gets released at Sea, Air, and Space every year, and it was quite a big lift. But we took, previously it had 200 plus USVs and all their specs and everything in it, and since then we've taken that and we've put it online on our website called at janusdefense.com. Go to the Navigator, and you can filter USVs by concept of operations, size, manufacturing, like an auto trader for USVs. And so now we only do about a 100-page annual. And I think we're going to start moving into quarterly, at least two, another one issue by the end of this year, something like a fall roundup, and then quarterly in 27. This is the goal. Yeah,
well, we'll be looking forward to it. It's
awesome.
Like I said, a great read. So,
thanks.
All right. Thank you so much. Appreciate it.
Elizabeth. Bye.
Bye. Thank you for listening to another episode of the AI Captain's Log. You can find me on YouTube, Apple Podcast, Pocket Cast, and Spotify. And if you find me on YouTube, please be sure to subscribe. Thanks so much, and happy boating.